and Camarao to discuss about the work. Suppose that your physics teacher asks you to read the entire chapter for the next day's discussion. That's a lot of work, isn't it? In scientific sense, you will not doing any work at all. How can that be? For this discussion, we are to state the operational definition of work, power, potential energy, and kinetic energy. State and explain the law of conservation of energy. In science, work occurs when a force causes an object to move in the direction of the force. In symbols, work is equal to Fd, where F is the force and D is the displacement. The SI unit of work is Newton meter. This unit combination is called the joule. In manufacturing company, how much work is done by a robot arm in pushing the box of tablets by a force of 32 Newton through a distance of 0.5 meter. For our solution, work is equal to Fd, where F is the force and D is the displacement. We are given the applied force 32 Newton and displacement 0.5 meter. Work done by applied force is Fd. Thus, work done is equal to 32 Newton multiplied by 0.5 meter. Work done is equal to 16 Newton meter. Since 1 Newton meter is equal to 1 joule, we can also say that the work done is 16 joule. Power is the rate of doing work. In equation form, P is equal to W over T, where W is the work and T is the time. The SI unit of power is watt. 1 watt is equal to 1 joule per second. What is the average power of a robot arm if it takes 1000 joule to lift a box in 25 seconds? Given work is equal to 1000 joule and time is equal to 25 seconds. To find the power, we will use this formula. P is equal to W over T, where W is the work and T is the time. 1000 joule divided by 25 seconds, P is equal to 40 watts. Energy is the ability to do work. There are many forms of energy: mechanical energy, heat energy, light energy, and chemical energy. In this chapter, we'll focus on mechanical energy. The sum of potential energy and kinetic energy is the mechanical energy. Potential energy is energy possessed by a body by virtue of its position or configuration. Gravitational potential energy is energy due to position. Potential energy is given by PE is equal to mgh, where m is the mass G is the acceleration due to gravity, and h is the height. The SI unit of potential energy is kilogram meter squared per second squared, or Newton meter or joule. Kinetic energy is energy possessed by a body because of its motion. Kinetic energy is given by KE is equal to 1/2 mv squared, where m is the mass, v is the velocity. The SI unit of kinetic energy is kilogram meter squared per second squared, or Newton meter or joule. Conservation of mechanical energy. Energy can neither be created nor destroyed. It can only change from one form to another. An equivalent statement is the total amount of energy in the universe or in any isolated system remains constant. This statement is called the conservation of energy. A system is considered isolated if it doesn't not absorb or release energy at the time it's being considered. To summarize our discussion, we define and give examples of work, power, and energy. We determine the difference between potential energy and kinetic energy. We state and explain the law of conservation of mechanical energy. For this topic, we have one value to be considered. Practice judicious use of limited resources. I'm Karla Camarao of BS Pharmacy from Our Lady of Fatima University. Thank you.